To Insight Engine Academy. In previous video, we have discussed what is a chemical equation, right? In this video, we will discuss what is a balanced chemical equation and how can we balance a chemical equation. So you can see balanced chemical equation. It is a chemical equation in which number of atoms of each element equal both sides of the chemical equation, reactant side as well as product side. Then it is called a balanced chemical equation. Let us see few examples of a balanced chemical equation. And in last video, we discussed one example, okay, formation of water from hydrogen and oxygen. Let me take the same example. If I take a hydrogen H2 plus O2 gives rise to H2O, right? We can identify here two hydrogen atoms. Let me write two black circles for representing hydrogen atom, and this hydrogen is combining with oxygen. Whenever we write hydrogen and oxygen in their pure states, we must write a O2 for oxygen, H2 for hydrogen. So here I am using a red circles to represent two oxygen atoms that are bonded with each other, right? Black circle represents hydrogen atom, red circle representing oxygen atom. Since we see two black circles, two hydrogen atoms, two red circles, two oxygen atoms, and now right side if you see two hydrogen atoms, I am writing two hydrogen atoms, two black circles, which are bonded with oxygen, which are bonded with one oxygen atom, which means I am writing only one red circle. You see now, number of atoms of hydrogen and oxygen are not equal reactant side and product side. If you look at here, this arrow mark, left side of the arrow mark, we see reactants, right side of the arrow mark, we see products. Right? Now, reactant side we have two hydrogen atoms, product side also two hydrogen atoms. Reactant side two oxygen atoms, but product side we have only one oxygen atom, and we can say the number of atoms of oxygen is not equal reactant side and the product side. Since they are not equal, what do we say? We consider this equation as unbalanced equation. We consider it unbalanced equation. So this unbalanced equation we have to balance in order to obey law of conservation of mass proposed by Anthony Lavoisier, right? According to this, during a chemical change, mass of reactants must be equal to mass of the products, right? And like in a previous video we discussed, if number of atoms are equal, then masses are also equal, right? Because atoms are the constituent particles which are responsible for providing mass of the substance. When number of atoms, reactant side, product side, before chemical change, after chemical change are equal, then masses are automatically will be equal. So we have to make number of atoms equal, and this is called, we learned in the last class, this is called what? Principle of atom conservation, POAC, principle of atom conservation. Let me write it the full name. It's a principle of atom conservation. This is a, we can say, outcome of law of conservation of mass, because mass is because of atoms. So when atoms are equal, masses are also equal. So in other words, law of conservation of mass is also understood by principle of atom conservation, where number of atoms remain same. Conservation, we learned conservation means remain same. What is remain same? Number of atoms of every element before chemical change, after chemical change must be equal, but the combinations may be different. You know what happens during a chemical reaction? No new atoms are created. but what happened? Rearrangement of atoms takes place. You see this equation, the circles, they are the best way to represent, to understand what happening during a chemical reaction. You see, before chemical change, before chemical reaction, two hydrogen atoms are bonded with each other, two oxygen atoms are bonded with each other. But after chemical change, you see, two hydrogen atoms are not bonded with each other. Instead, they are bonded to oxygen atom. So atoms are same, type of atoms are same, okay, but the arrangement is not same. Arrangement is different. Due to different arrangements, different substances with new properties are formed. This is the main aspect of chemical reaction. During a chemical reaction or as a result of chemical reaction, always a new substances with a new set of properties are produced, right? We see here hydrogen. Let's see the properties. In this, we understand the main important aspects of the chemical reactions using this chemical equations. Hydrogen, let me tell you, hydrogen is a gas. What type of gas? It is a combustible gas. Hydrogen is combustible gas that undergoes combustion, it burns, right? Then what is this? O2. O2 is oxygen. Oxygen, we know it's a supporter of burning. In the absence of oxygen, nothing can burn. Oxygen is compulsory for burning, so it's a supporter. Now what is it? Hydrogen is a combustible gas, whereas oxygen is supporter of that burning process. Whereas when these two react with each other, they give a substance called water. Water, we know water character. Water is generally used to put off the fire. It is exactly opposite characters that of its constituent atoms, hydrogen and oxygen. Hydrogen is a combustible, oxygen supports, whereas water, which is formed from them, is extinguisher. It put off the fire, right? So as a result of chemical change, the substances that are produced, they have completely new set of physical and chemical properties, right? Now, and one more difference between these reactants and products we see. Hydrogen and oxygen both are gases at room temperature, whereas water, the substance formed here, is a liquid at room temperature. This is understand there is a lot of differences between reacting substances and the products that they obtain, okay, from the reactants, right? Now coming to this, according to principle of atom conservation, atoms should be equal, both sides, reactant side and product side should be equal, right? But in this equation, the number of atoms are not equal, okay? So we have to make the atoms equal. So the process of making number of atoms of each element, reactant side equal to product side, is called a balancing chemical equation. Balancing chemical equation. This is our today's topic. Now let us see how do we balance this equation. So I have this equation, hydrogen, oxygen and water. Okay, now let us write what are the elements present. So we have to first understand whether the equation is balanced or not. The one way is drawing the circles like this with different colors. This is one method. There is another method to understand, to verify whether atoms are balanced or not, right? For that, let's make a small table. Let me write element and number of atoms of each number of atoms. That's right, it's enough. Number of atoms, right? Number of atoms, both sides will write left hand side and right hand side. Number of atoms, left hand side of the arrow mark. This arrow mark separating left side, right side. Left side are the reactants, right side are the products. Now you see element, the different elements, right? We have, right? The elements we have, what elements we have here? We have two elements, hydrogen and oxygen, two elements, right? And number of atoms that are present, left hand side and right hand side. Let us make a small table like this. So hydrogen atoms, left hand side, two hydrogen atoms, right hand side also two hydrogen atoms. You can see two black circles left side, two black circles right side. Two hydrogen atoms left side, two hydrogen atoms, okay, right side. We have oxygens. Two oxygen atoms, O2, right? Two oxygen atoms left hand side and only one oxygen atom right hand side. Okay, now we see hydrogen atom is balanced. Oxygen atoms are not equal. They are not balanced. We have to make it equal. For that, what we do? Okay, let me write the equation, skeleton equation as it is. H2 plus O2 gives rise to H2. I just write correct formulae. We have to write correct formula. If you write wrong formula, you cannot balance the equation. Even if you balance, it will be meaningless, right? So we have to write correct formula, chemical formula of reactants and products, and now we can balance it. Okay, for balancing the equation, we should not change the chemical formula of the reactants and products. Reactants, hydrogen is written H2, oxygen written O2, water is written H2O. That's all. We should not change the chemical formula of the substances. Instead, we can change the number of molecules. We can change the number of molecules. Here, the blanks that I'm writing here, we can write any number. They are generally called coefficients, right? By changing the coefficients, we can change number of molecules of reactants and products. So ultimately, to make number of atoms of each element equal both sides of the chemical equation. So for this, what do I do? Right? If I see this table, hydrogen atoms we see are balanced, but oxygen atoms are not balanced. We have two atoms left hand side, only one atom right hand side. We have to make right hand side equal to the left hand side. We cannot make number of atoms one reactant side because oxygen must be written O2 only, water must be written H2, right? But we can change this number, oxygen, we can increase the number of atoms right hand side. Since we have one atom, okay, let's see how do I balance. What I do is, you just see this, two oxygen atoms I have left hand side, I have only one atom right hand side. This one molecule of water contain one oxygen atom. If I make it two molecules, then they contain two atoms of oxygen, right? Oxygens are balanced now, but hydrogens are not balanced now. Two twos are four hydrogens. We have four hydrogens product side, only two hydrogens reactant side. So what I do, I just multiply, make two molecules. I make it two molecules. Two twos are two molecules of hydrogen has four hydrogen atoms. Whereas, one molecule of hydrogen has two atoms. If we take two atoms, two molecules, then it contains four atoms. That's it. So four hydrogens, two oxygens, balanced. Okay, this is the balanced chemical equation. How do you write? This is the equation that we get is balanced chemical equation. Balanced chemical equation, right? Let us understand, okay, balancing chemical equations, taking few more examples, right? Let me take example 2. Example 2 is burning of a gas called propane. This propane chemical formula is C3H8. What is propane? Where do we see propane? This propane, right, is actually a component gas of LPG. Component gas of LPG, right? Propane is one of the component gases of LPG. Other component is also there in LPG. So let me write other component of LPG is butane, which is written C4H10. This is another component. So for us, let us focus on one of the components of LPG, that is propane. So when propane burns, what happened, right? Let's write propane on burning, it combines with oxygen, produces carbon dioxide and water vapor, right? And this word equation can be written in terms of, like, it can be written as chemical equation using their correct formula of all the reactants and products. Okay, this is arrow mark separating reactants and products. Propane, as we know, C3H8, this is C3H8 plus oxygen. How do we write? Do we write just symbol or its formula? We must write its formula, because single atom of oxygen is unstable, it doesn't exist. It exists in combined state, O2 state, gives rise to carbon dioxide. It's CO2 plus water, I'll write H2O. Okay, let's write a table. Okay, the elements present, different elements present, the element, and let's write number of atoms, left hand side and right hand side. Let us write a table, a small table, to verify easily number of atoms of each element in this involving in the chemical equation in burning of propane. Let's check C3H8. Let's write the elements that are present are carbon. We have carbon, hydrogen, oxygen. I've already told you in the previous video that whatever type of atoms present reactant side, the same atoms must be present right hand side, product side. No new atoms are written. Okay, or we cannot leave any atom not writing, right? All the atoms, all the elements that you write left hand side must be written product. So let us check here. Carbon is present left hand side, right hand side, maybe number of atoms are not equal. Hydrogen atom is present, hydrogen atoms are present, oxygen atoms are present, oxygen, it may not be equal, it cannot be equal every time. We have to make it equal. Okay, that is what called balancing a chemical equation. Let's write elements. We have carbon, we have hydrogen, we have oxygen. Now, left hand side, if you check left hand side, how many atoms are there? Number of atoms of carbon, I'm writing first carbon, 3 atoms. Okay, hydrogens, 8 atoms, oxygen, 2 atoms. Product side, right hand side, let's see, there is only 1 atom of carbon. Okay, then hydrogens, we have 2 hydrogen atoms, oxygens here 2 in CO2 and 1 in H2O, total 3 atoms of oxygen product side. And now we have to, okay, look at this, verify whether all these atoms are equal or not equal. You see, carbon 3, 1, hydrogen 8 and 2, oxygen 2 and 3, not equal. Okay, no atom is balanced here, no element is balanced. We have to make them equal. So for writing that, for making it equal and writing a balanced equation, what do? We write the skeleton equation. What do I say this is? This is called skeleton equation. This skeleton equation may be balanced or not balanced. Skeleton equation, most of the time skeleton equations are not balanced. They only just represent what are the reactants and what are the products. That's it. Skeleton equation. Now I'll write the skeleton equation as it is. C3H8 plus O2 gives rise to CO2 plus H2O. This is a skeleton equation. And we did what we did in the earlier equation. We did not change the formula of the chemical substances involving. They may be reactants or products. We must not change the chemical formula of substance, right? C3H8 representing propane, O2 oxygen, CO2 carbon dioxide, H2O water. Now we can see this table, atoms are not equal, so we have to make it equal. So we have 3 carbon atoms left hand side, right hand side there is only 1 carbon atom in CO2. Okay, if I take 3 CO2 molecules containing 3 carbon atoms, yes or no? One CO2 molecule contain 1 carbon atom. If I write 3 molecules, if I take 3 molecules, it contains 3 carbon atoms, right? So 3 carbon atoms right hand side, 3 carbon atoms left hand side. All the atoms that are participating here are changing their form and existing as a new substance, as a product, right? This is the coefficients can be changed. The coefficient value represents the number of molecules of each substance written, the substance written. So here if I write 3 means 3 CO2 molecules. Okay, done. Carbon is balanced. Hydrogen, how many atoms, Rana? 8 atoms left hand side, 2 atoms only right hand side. We make it equal. 8 atoms, we have 2 atoms. So 1 molecule of water has 2 hydrogen atoms. If I take 4 molecules, 4 2s are 8 hydrogen atoms balanced. Right now it's time for checking oxygen atoms. So we have 2 oxygen atoms left hand side, but right hand side 3 CO2 molecules. 3 2s are 6 oxygen atoms in CO2. 6, and here each water has 1. So 4 1s are 4. 4 here, 6 here, total 10. So I simply write 5 here, 5 O2, 5 O2, 5 molecules of O2. So 5 2s are 10. Now you can see now we can verify. If you want, we can verify. Let's write again. Number of carbon atoms, hydrogen atoms, oxygen atoms. Left hand side, how many atoms? Right hand side, how many atoms? Left hand side, 3 carbon atoms, hydrogen, 8 hydrogen atoms, oxygens, 5 2s are 10 oxygen atoms. Right hand side, if you see 3 carbon atoms, 4 2s are 8 hydrogen atoms, 3 2s are 6, 4 1s are 4, total 10 oxygen atoms. Now you see this table. This table is used to verify. What is it? It's a verification. It's a verification step whether the equation that we have written above is balanced or unbalanced. If you look at it, right? If you look at this table, right? Carbon atoms 3 and 3, hydrogens 8 and 8, oxygens 10 and 10, balanced. So this is how we balance chemical equations, right? And this method of balancing chemical equations, it has a name, and the name is, this method of balancing is called hit and trial. Hit and trial method of balancing chemical equation, right? Hope you understand this method, hit and trial method. Among various methods, this is the easiest method of balancing chemical equation. So we do follow this, and in our syllabus also we have this one method of balancing chemical equations. And for your easy understanding, if you want any other method, new method of balancing, I would also like to give you another second method of balancing equation. It's called algebraic method. So let's do balance one equation in a new method, in another method. Let's see.